In this video we will talk about the fifth theorem, that is about the product rule. So now we're talking about fifth theorem, that is about product rule. That if we have a function of the type this, there are two functions, f of x and g of x, and there is y is a function, is a product of the two individual functions. Then what should we do in order to find the derivative of such functions? So the theorem says that rate of change of the function with respect to the independent variable x is equal to now the rate of change of the first function, the second function remains quiet, that it doesn't have any impact of this on the other function at the same time, but there is a positive sign, then the first function stays same and the rate of change of the second function with respect to x. And we can also write it the product of the function, the second function, and the derivative of the first function plus the product of the first function and the derivative of the second function. Let's prove it by using the definition of the derivative. Let's prove it. Y is equal to f of x and g of x. Then adding change. Then subtracting the two terms. We get f of x plus this and gx tilde x minus f of x and g of x. Now we have to add and subtract a factor. In this term we have to add and subtract f of x g x plus change in x in order to make factor of 2. Then now writing it as f x plus tilde x minus f of x, I take this and this value, taking out common gx plus delta x from both terms, gx plus delta x, and now this and this, the common value is f of x, so we can write g x plus delta x minus g of x. Now the next step is to divide the term with the change. Now dividing the terms with the change, and this whole with the change and this whole with the change delta x. Now we have to apply limit on the both sides. Limit delta x approaches to 0. Limit of this, that f of x plus delta x minus f of x over delta x, and here g of x plus delta x plus limit delta x approaches to 0 g of x plus delta x minus g of x, and here change f of x. Now talking about the limit, then this whole from here to here is the rate of change of y with respect to x, that the rate of change of f is the function with respect to x, and this is by applying limit we only get g of x because this becomes 0. And talking about this factor, this whole from here to here is g of x, the rate of change of g of x, and this will not change. So our final statement will be where f dash of x, g of x plus g of x and f of x, g dash of x and f of x. So this is what the theorem says about the product rule, and that we get proved by the definition or by first principle. So we'll take an example. If this is the function x minus 5 square root of x plus x, then we have to find the derivative of the function. Then d by dx of y is equal to, by applying the product rule, we can write the rate of change of the first function, the second function as it is, plus the first function as it is, and the rate of change of the second function. So d by dx of x minus d by dx of 5 and delta x plus x as it is, plus x minus 5 d by dx of under root x plus d by dx of x. Now dx over dx comes out, this is 1, this is 0 because that y is a constant function, and under root x, we know that under root x can be written as x to the power 1 by 2, and we know that under root x is x to the power 1 by 2. So we can apply the power rule here. So will comes out with this 1 minus 0 under root x plus x and plus x minus 5. So by applying theorem, half comes down, there should be decrease 1 by 2 minus 1, and dx by dx is obviously 1. So it is under root x plus x minus 5, 1 by 2, x to the power minus 1 by 2 plus 1. So this is the final answer. This is the function, and the derivative of the function, by applying the product rule and some other previous theorems, we can write the rate of change of y with respect to x in this form. This is the answer, and we will talk about the next theorem in the next video. So stay tuned. Goodbye.